and I have around 15 years experience in development. I started Android, when there was 1.5 Android version out there on the market with single device, beautiful times. So I have been working for Bright. I started working then 2 months ago, and I started working on a project, a fresh project using Compose, no view system and XMLs we had before. I was very lucky, but I started playing with Compose much earlier, and I really felt love in it with this platform. I think it's much better than XML, and I have learned few things about it, learned some patterns, and that's exactly what I would like to share with you today. But first, I will start with some basic of Compose, because I can imagine that maybe not all of you already try it. You might be working on some, older projects that already have views implemented, and I know it's not that easy to, rewrite entire production code right away. So I will just, explain what is the composable, because we'll be talking about that. And composables are the building blocks of the UI in Jetpack Compose. This is what we have in the previously we had views represented by classes, but composables are represented by function. And on the screen you can see an example of that. We have a function called main screen. Usually composable starts with the capital letter, not the small, and I believe Android Studio will even prompt you to use capital letter if you write such function. And what's important, we have annotation composable, and that basically what makes it a composable, right? Makes sense. And the state of the composable, so where the UI reads the data from, are the properties. And on this screen you see we have name of type string, and on click is a callback function, simple lambda. And in Compose, whenever the state changes, Compose is recomposed. It's or you can say recreated. And also, even if the lambda is changed, like the new lambda could be created by the caller, and then it triggers recomposition. You can easily find out some interesting materials about recomposition, but it's not part of this talk, so we'll skip that. But that is what it makes the composable. And then inside you have some other composables and in this case we have column and text, and that comes from Jetpack Compose library. Column is a very simple list you can use. There's also a lazy column that is kind of replacement for recycler view. And that's it. And this composable is stateless, and I will explain shortly, what that means. Because on the next slide, I have modified this composable a little bit to make it stateful. And difference between the stateless and stateful is that stateful composable manage on state, while the stateless composable gets the state entirely from the parameters. So you can imagine that. Oh, sorry, my daughter is shouting. So stateless composables never ever change their look without parameters being changed, and the stateful can actually change itself how it looks like without the parameters being changed. I think that's the simplest explanation. And the first pattern I would like to, or maybe I will first explain, what you see on this slide as well. We have a property text field value with remember function and mutable state of. Remember and mutable state of are special functions from Compose. Remember allows to store property information between recompositions. Otherwise, if you would have no remember, whatever property was assigned would be then recreated as well. But thanks to this function, it's stored. And mutable state of is another function that you can use to wrap any object, any property. And this one makes it so whenever the property is changed, it will automatically trigger recomposition. I know it might, if you're not familiar with those concepts and Jetpack Compose at all, I know it sounds maybe a little bit complicated, but trust me, it's not. When you try it first time, I think you will get it very quickly. So we can move on now. The first pattern I want to talk about is called state hoisting. On a slide, there's a link, and that link and other links throughout the slides I will be sharing later in chat, so don't worry, you don't have to take pictures or manually write that down. So state hoisting is a very simple pattern, and it's about transforming stateless composables into stateful. And why you would do it? There are several reasons. Some of them are listed on this on the documentation I'm linking here, but I primarily would like to focus on testing and reusability of this pattern. So I would like to show you first, how we can transform the previous stateful composable into stateless. As you can see, this line with text field value by remember, that was deleted. I just kept it, commented for the convenience here. And that was moved to the parameter. So that means whoever calls this function is responsible for providing the value. And also the text field that we have used here is using now onTextChanged callback that is also provided from parameters. So state hoisting basically means that we move the state from inside to the parameters, to the outside. And that's it. That's basically the concept. And it is really, really good to understand it and apply in various places. And I want to share next, like one of the examples where I use it and it worked for me very, very well. So whenever we build some screens in our app, that will be also represented by composable function. It will be like somewhere at the top of the application. And what I do basically is I create two functions with exactly the same name. Like here you can see we have the main is taking the parameters that you could see earlier on this previous slide. That's exactly the same function here. But it is wrapped in another function with the same name, but here we provide view model, which is a classic view model from Jetpack libraries. And the responsibility of this top main screen is to handle the state. This example, I know it looks very simple. We just read the UI state and provide the properties. But you can imagine that in a bit more complicated application where you have a little, more things going on with the state. And also if you have some state handled by the UI itself, because not everything can be coming from the view model, you can have some UI logic there. This is where you would handle, and then you just pass raw properties and handle callbacks from that inner main screen composable, and that creates very nice separation of concerns. It also makes testing much easier and writing previews, because then you work basically with testing and previews, you work with this simple version where you just provide different properties, and it's much easier to maintain. Then you don't really bother with the view model, and you don't have to instantiate view model, and you just don't think about it. And on the next slide, you can exactly see an example of what I just said. So on the left side, we have a preview for that screen where we can provide some simple values. And you can have multiple different versions of the previews. This one is just showing some static properties. What you should know about preview, it always renders single frame. of the composable. It's not automatically rendering animations. You can do so, but by enabling interactive mode. But by default, when you browse your code and you just look on the right side where the preview is, it just shows the single frame. So it's just easier to create it that way. And then on the right side, we have a very simple test where I can also handle state myself, and for example, if there is something more sophisticated in the production code, I can make it simpler here just for the testing purposes, and I have full control. And that works, I would say, pretty well. But state hoisting, it has one, I would say, trap, let's call it. Because imagine if you have a hierarchy of composables, quite complex, and you have like composable, incomposable, and so on and so on. And you would like to then transfer all the composables all the way from stateless to stateful. So that basically would mean that you would be pushing all the data to the highest, to the top level composable, and that would mean you would have to in every composable in between, you would have to add multiple properties that are required by the lower composable somewhere, being used there. And it's not really a good practice. You should avoid that, because then you create unnecessary awareness in those in-between components. And so the question would be here, okay, so how do we solve that, right? And there are a few ways. Just let me drink some water. So first rule is that you should plan and limit the number of places where you want to apply this state hoisting to benefit from it. Because having stateful composables somewhere down below isn't a bad thing on its own. Using state hoisting made things easier, but it can also make it harder if you use it everywhere, just because you want to use it because someone told you to do it. Second solution could be using composition local, and that's something I will show briefly in a moment. And then there would be also slot API pattern that I will cover in this talk as well. So composition local, that is very cool feature. If we have any Flutter developers here, this is basically the same as inherited widget. And I guess that's all you need to know. But for everyone else, composition local allowed to basically use some data in the lower levels of the UI hierarchy that is provided by the upper level. So one of the examples that you might be already using is material theming. On the right side, you can see example where we have some my app function with material theme, where we provide and set some different values for colors. And lower we have some text label composable that is referencing material theme with object class, because at the top the material theme is a function, and material theme dot colors dot primary, that is a Kotlin object. And basically this mechanism is not used just for the theming, but as you can see on the left side, it's used for many different things, like for example referencing context from composable. I think it's quite common to access context, and this is how you do it. You just call local context dot current, and you can get it. That screen on the left actually come from the screenshot from Android Studio. If you just go into any composable and start writing local, you will see exactly the same thing. I am also using this myself right now, not only for providing the theming, but also for navigation. And we have some like a global messaging we can call from any lower composable to the global one, where we have scaffold with the snack bar for example, and that works pretty well. So as I said, I'll be talking also about this slot API pattern. This is also very commonly used pattern in Jetpack Compose. One of the examples where you could see it is scaffold, composable. Scaffold is an object you might be already familiar from the view system that handles, top bar, bottom bar, floating action button, drawer, and I think something else. Can't remember exactly. And here in Compose, it's not different. It also do the same. But as you can see, the scaffold on the left side uses lambdas to provide like the top bar, bottom bar, content. And on the right side, there's like an example I just like made up to show how that could be differently, where you would be providing some simple properties like title, actions, and so on. But if it was made that way, it wouldn't be flexible because you would have to stick to many properties that you have to pass down from scaffold to the lower composables, and scaffold doesn't really care in what's in the top bar, what's in the bottom bar. It just handles positioning and navigating, placing those composables in the correct position, but it doesn't care what the title is and such. Hold on. So what slot API is about exposing in Compose a lambda that takes another composable that then you can use inside your composable. Like here we providing top up bar to scaffold. And this is very useful for several reasons. And when I mentioned this solves the state hoisting problem, I can present exactly on the next screen where we are creating, as you can see, a scaffold, inside scaffold top up bar, and then up bar uses text and icon. And what you can see that this text doesn't need the parents to provide the data because it can directly access view model, and the top up, they don't care about this value. So that's exactly how you can solve the problem with the slot API. And whenever you will be like designing your own composables, maybe writing some complex views that you want to use somewhere, I highly encourage you to ask yourself if this slot API would be useful for you to maybe improve the reusability and avoid the state hoisting problem. One of the examples, this is actually taken from like the real code. This is an example of a project list column. That's the composable I was creating. And this column is responsible for loading the children. And whenever we scroll, there should be floating action button appearing. And when we scroll on that button, the list should scroll back to the top. It doesn't care at all what kind of children there are, what kind of items. And of course, in the running application, those items are a bit complex. Those are cards with some text and actions and so on. So there is something going on, and but the list doesn't care. And as you can see on this test, instead you can see this class lazy paging items with the string type, and this is what provides the data. And I didn't have to use the object that normally provides the data in the running application. I could easily replace it with string. And if it's just a string, then I could also easily create those project names at the top with the range from 0 to 50 and made up the name. And then I could easily use the text composable to act as a child of the list. And then I could test it easily. So as you can see, I have this very clear separation of concerns from the list and the actual children. And few takeaways from the slot API. You can use it to move children to the level of the parent, so data can be passed much easily. You separate the responsibility between the parent and the children, and that enables the parent to be used with different children, and vice versa, children to be used with different parent. I hope that was quite clear enough. And I have a few more extra tips. That's something I've been wondering when I started with Compose UI. Like asking myself again, what should I be testing? How should I be testing UI and so on? And I figured that whenever I have those stateless composables that never really, don't have any interaction, never changed, it's best to use previews. Sorry. It's the best to use previews. You can have multiple versions, and that should be enough. I know there is plugin for Gradle that allows to save all the previews from the project as the images, so you could integrate that on your CI, and I think that should be good enough. And then write tests only for the ones that have some interaction, like the list I was showing you earlier. So basically, or for those stateful ones, and I think that is reasonable approach. So don't write tests for checking if there is a specific color set, because I think that is just a waste of time. But it's just my opinion and my approach, so use it if you like it. And then another tip, box with constraints. That is a special composable. It's very useful when you have some adaptive UIs, and what that means is that whenever you have to decide what kind of view you're supposed to be showing depending on how much screen space you have available, then this is what you can wrap your composable with box with constraints, and that will provide you parameters like min and max width and min and max height. So you can very easily check if you have enough space for a larger composable, or maybe you should use the smaller one, or maybe different, or whether it should be a list maybe, or some grid and so on. Another tip, whenever you create your own composables, it is very good practice to have modifier property as one of the parameters. And usually you can set that to some default value, which would be the modifier object itself. But that way, wherever your composable is used by some parents, wherever it's called, you give the parent possibility to modify the children. For example, set some alignments, maybe extra padding, and so on. Because the child may not know in what circumstances, in what context it's used, but parent knows. So we have to somehow expose this functionality. And last but not least, whenever you start your app, think about theming, how you can customize it for your own needs if the one that is built in doesn't suits you well. Because I think that's the best way to provide like styling properties to your composables, and modify that on configuration changes, or like when users switch to light, dark, and do some other things with the app. It's much easier, and then you can apply multiple themes in your application rather than worrying when you have some direct access to some values, and then it's very easy to maintain and apply changes in the future. So that is all. Thank you so much for listening. I hope you enjoyed that and learned something. I think it's time for some Q&As. I will stop sharing maybe, because I didn't see chat, by the way, if there was anything written there.
Thank you, Damian. There is a lot of knowledge that you shared with us. There is one question, as I saw, from Alexander. What do you think about leveraging dependency injection frameworks like Coin for avoiding deep state hoisting?
Yeah, I think that's something good to try. I actually was looking into Coin myself to try it out, but didn't have time yet to apply any dependency injection. I didn't need this so far. But yeah, definitely. I mean, if that solves your problem, make it easier, why not? But I didn't personally feel like a very strong need to for any dependency injection so far with the composables I created.
I don't know if that was question about it, but dependency injection normally is used in view models, and when you have application that is using only composables, like one activity application that every view is a composable view, then you are still using view models and you are using the injection in view models. Am I right?
Yeah, I mean, I actually for dependency injection use Hilt at the moment whenever I have to provide.
But still in view models or in
in view models and all the layers down, like domain and data layers. In Compose, I simply didn't have the need for that so far.
Okay, I saw one comment on Twitter the other day about manual injection in Composables. Did you heard about that?
No, I don't think so. No. Maybe I did, but forgot completely.
All right. I was wondering how that works, but I do not have any experience with that. I just saw one tweet about it. Do we have any other questions to Damian? How about inlining functions? Does it leverage better performance?
You mean like inlining function for composable? I don't think that's possible, to be honest, but I haven't tried that myself. But it's interesting question. But I would imagine that I think it might not work because with the annotations. That's my state. I can't tell really much more about that. Oh, Piotr is out. Maybe he's trying already inline functions.
I just needed to switch the rooms. That's why I turned off the voice and camera, and I'm settling down in the other room. So just give me a few more seconds and I will start with my presentation. Thank you,
Sure.
Damian, once again. And maybe there will be some questions in the third part of our meeting. Don't be shy, ask more questions. Compose is new. Or maybe share with us how many of you are using Compose already on production, and how many of you are using Compose in your pet projects, and maybe some of you are not using Compose at all, like you didn't even start yet. Okay, different room, different setup, but I'm ready to go. So I will start with my presentation, and I hope we'll talk more about Compose in the third part. In the third part of our meeting.
Okay, so thank you. I'm hiding myself for now.
All right, thank you. So, okay, just please one person just give it a thumbs up that you see the screen, interact with Composable Canvas. Or Damian, can you say
It works. Yeah, it works.
Yes. All right. That's great. Okay, so I will start with my presentation about interacting with Composable Canvas. So my name is Piotr Prus, and I'm mobile tech lead at Early, and I'm also a GDG Free City organizer. So I will be talking about this view that you can see right now on the screen. It's Composable Canvas with some animation, interactions, and state management. And short agenda for this talk, we'll talk about Android Canvas, how Android View Canvas works, and how Canvas is working in Android. So there will be a short recap. Then I will talk about Composable Canvas, how this canvas in Composable works, how we can initiate it, how can we build Composable Canvas function. Then I will share with you some key differences that I found, and then we will do the implementation. Of course, not step by step every line of code, but just to have the better understanding how I implement this view. Then interactions that you can see on the screen, the click, the temporary click, then the animations, state management, and at the end, I will show you how I test this view. So starting from the beginning, from the coordinate system in Canvas, I hope everyone knows how this works, but just a short recap. We have two axes, X and Y, and X is increasing from start to end, depending on which layout direction you're using, and the Y-axis is increasing from top to bottom. So imagine this this view on the right. So this is a sample of our bar chart. Those vertical lines are bars, and to draw something like this in Canvas, we need to space every element in the canvas manually. So we need to know each distance between those bars, and there is important thing, very important thing when you're doing canvas drawing in Android is padding. So from on this picture, I marked with blue padding on the left and on the right side. We need this padding because if we would like to draw something at the very beginning on the canvas and we'll have some width, then we can lose something because it's not in the canvas. So we need to ensure that we are drawing the center of our drawing and the width is not extending the canvas space. So hitting to our bar chart, we will have those two paddings on the left and on the right, then two paddings in top and bottom, and our draw area will be in the middle. So nothing will extend our canvas, nothing will be overdraw somewhere in void. So a short reminder how what functions have Canvas, what can we use? We can use draw rectangular, oval, line, then we have function for draw text, draw bitmap, and for more complicated things, we have also draw path. So for our bar chart, I will use those three functions, draw rectangular for vertical bars, then draw line for those horizontal helper lines, and then draw text to add at each bar the value above the bar. One thing about Composable Canvas, I will talk about that more shortly, but Composable Canvas do not have function draw text that is needed in this implementation. So how Composable Canvas looks. When you click when you search for Canvas implementation in the documentation, and composable functions are really well documented, well done Google, the canvas is just a spacer with modifier draw behind. I was really surprised by that, but this is massive. This is something that gives you a lot of opportunities because you can use canvas on each composable. Each composable have modifier, so you can always call draw behind and draw something manually. So as you can see here in this second code snippet, you have my canvas function, and this is a box with size of 100 dp with background white, and then we have this draw behind modifier, and I'm just drawing rectangular with color blue and size of 20 pixels. And here is the result of this. So we have just a box with small rectangular of 20 pixels in the top left corner. So taking another snippet, this is almost exactly the same code. We have a box with background and draw behind function, but the result of that is exactly this, is nothing. Canvas is not working when we are not giving fixed size. So imagine the real canvas in the real world. You can't draw anything without a size, without a canvas. So here it working the same. You cannot draw anything on the canvas if the system do not knows its size before drawing. That's why we do not have any result here. Another thing, and here is the copy from documentation, that you must specify size with modifier, modifier size or modifier fill max size if you are using parent with size, but you need to specify the size. And here is another snippet and something that I would like to share with you. Draw behind is drawing as it is named. You can figure it out. It is drawing behind your actual content of the box. So if we adding draw behind to the box and we are adding another view in the content, like this one, box with size of 20 dp and background red, then we will not see our canvas little 20 pixel drawings. We will just see the red rectangular because this is draw behind. But we can easily fix that. Just add a line to bottom end for our red box, and then we'll have two boxes. So our box that have the draw behind function have 100 dp size, and in the left top corner we have drawing done using draw rectangular function from canvas, and then in the bottom right corner we have box colored with red. So key differences that I found using Composable Canvas and previously using Android View Canvas. When I was using Android View, I was always struggling with which function I should use to calculate dp to pixels and pixels to dp and so on. And it was always an issue for me, always trouble how to calculate it properly on which on each device and what function I should really use. Those two are taken from Stack Overflows, and there are discussion which one is better, and people are discussing about that. I always thought that this is something that I'm struggling with, and in Compose it's pretty simple. You can just call local density, which is composition local, something that Damian already mentioned in his presentation. And if we would like to calculate horizontal padding for 20 dp and having that in pixels, because everything that we are drawing in Canvas need to be drawn in pixels, it is quite easy to calculate that. We are just giving width density, and then we can calculate any number to pixels. Another thing is taking care of size. As I said before, size is something that need to be fixed and known before you start drawing into your canvas or onto your canvas. And using Android View is not straightforward, in my opinion. We need to check on each size change if the view or height change it, and then update our width. And in my opinion, is problematic. And when you are using Canvas from Composable, there is easy to use function methods, not methods, sorry, variables. Field variables is we have the variable size with two fields, width and height, already in pixels. So it's easy to use those values when you need to calculate something in your canvas. So about this draw text function. Unfortunately, this function is not part of the composable canvas. But Android graphic canvas, which is Android View Canvas, has this function draw text. And we can easily use functions from Android View Canvas in our composable function. And here it is how we are doing that. We can call this, which is draw scope, and then call draw context.canvas.native canvas. And from now on, we can use all the functions from Android View Canvas, including draw text. So we can draw the text into our composable canvas. If you think about text paint that is used here, the text paint needs to be used also from Android graphics library. So the paint class is different than the color or paint class from Composable. So be aware of that. And last thing about this draw text, back in June 2021, I made this feature request for adding draw text functionality to Canvas component in Jetpack Compose, and it is already P1, how it's called, priority. This is the highest priority, so I hope the Google team will soon manage that, and we will not need to use native canvas, and we can use draw text from our composable function. So let's start now with implementation. On the right top corner, you can see the bar chart for your reference, and I will go briefly through few things that I think are important to make this bar chart. So first, I choose raw to have the horizontal scroll possibility. I fixed the height for 150 dp and add some initial padding, but this is not canvas padding, it's the whole raw padding. Then I'm calling density, local density current, because I will use this density everywhere in my canvas to calculate values from dp to pixels. Then we have horizontal padding that will be used inside the canvas, as I said before, to do not have any drawing that will be over the canvas draw area. Then I'm calculating distance, and for those bars it will be 26 dp, and then I can calculate the actual width of my canvas. So as I said before, this is something that need to be known before we start drawing. And I calculate that taking distance multiplied by size of my list and then adding 2 horizontal padding at start and at the end. And then in this row, I can call my canvas and use fill max height. So take the full height of the row. And as my width, I will use my calculated width, which is multiply distance by size of the list. So I will not miss anything, and I can then easily draw any single bar. So before we jump to the bars, I will draw a few horizontal lines as a helper lines. So I'm repeating 5 times the function draw line with color gray, and then there is an offset, and this small padding is my top and bottom padding, and I need to add that to each offset to do not have the line on position 0, 0, so the line is visible. And then is my end offset, which is size width, so the line will be from the start to the end. And also we have this vertical position, the Y position with small padding, and line distance times number of repeated position. And now let's jump to those bars. I have here the list that is called bar areas. And bar area is something that that I added to the code, which is data class that have 4 variables is index, so I know which bar I actually drawing. Then we have the X position start and X end. This is something that I will use later on for selection. So I will know exactly which bar I selected. And then there is a value. So this is something that I will use to display the number and also draw the height of the bar. So yeah, this is also the implementation, how I mapped the list to those bar areas list. So the important thing here is to add this horizontal padding, as I mentioned before, to do not overdraw our bars or lines. And the X start and X end, as you can see, have distance multiplied by the index. And then we have horizontal padding added to those two. This is something that you need to remember every time when you are drawing on the canvas, to always add those global padding, horizontal, vertical, whatever, but to add that to be in the right spot, on the right position on your canvas. So as I said, the value will be used to calculate the bar height. I'm using here some scale. I will not share how this is calculated, but I just use some scale to have better illustration of the bar heights. And then we have draw road rectangular function, which take color and then top left corner of the bar. As you can see, we always use this horizontal padding as a global padding, and then there is X and Y coordinate for the top left corner of the bar, and then we have size and corner radius to just round those bars. And for each of those bars, I need also to add the text into that. So we have draw into canvas, and we are using canvas.nativecanvas to draw a text, as I mentioned before. And we have some text, which is just the value, and we are adding again horizontal padding and painter that is taken from Android graphics library, so native Android view. And you can see here that the text size is calculated with density, and this text is not using dp, but you can also use sp for text, and this is converted to pixels. And the paint, as I mentioned before, is used from Android graphics library, and this is the implementation of the paint. So here it is. This is how this bar looks right now. You cannot click on it, but you can scroll it. Each bar is draw. The helper lines are also drawn, and we have above each bar we have a number. So now interaction, the funny part, how the interaction works in Composable in general, and how I used that in this canvas. So in Android views, interaction are you can make your custom interactions using motion event, and in Composable you need to use pointer input. And what is this pointer input? So we have a special modifier that you can apply to every composable, because every composable have modifier. And this pointer input have a launched effect that suspends use suspend function and wait for any input that will occur to this composable. And we can use number of functions to detect what type of input user did to this composable function, composable view. So I here show you how I built the start gesture modifier. So I will make this start gesture function that will take on start high order function. I starting with modifier and giving the interaction source. And I'm remembering here mutable interaction source, which is this class allows listening to interaction changes inside the composable. Then we can start our pointer input with this interaction source, which is needed to listen to those interactions. Then we can call for each gesture to check every gesture that appears. And since this is a suspendable function, we can use correlating scope here, and then we can await for pointer event scope. So we are awaiting for any pointer that will appear, and then we can await for the press down. So this is something similar to motion event dot down, if I remember correctly. So I called it touch, and whenever my suspend function will await for first finger down or pencil down or whatever, I will call my onStart function and give this position of this touch. And now I will show you how I construct the tap or press function, because to make those gestures on Composable on this canvas, I thought I need 3 different gestures. I need to know where user put the finger, if the user cancel this touch, or if user complete, so taking up the finger, so they are performing click event. So let's start from this on start. That we already show on the previous slides. We are just awaiting the finger down, and the cancel is something that we are here waiting for up or cancellation, and this is the function from this await pointer event scope. We can call function that is called wait for up or cancellation. And if up is null, that means that our user canceled the event, and I want to know at which position user cancel, so I will cancel also my selection. And else, if the app is not null and have some data, then we can call on complete. So the user completes the touch, completes the click, and I will know at which position user clicked on my composable function, in that case, canvas. But you can use this modifier on every composable, because this is extension function to the modifier, so you can use this anywhere. And this is how it looks entirely. I will later on share the GitHub repository with all the code that I'm showing you right now on this presentation. So now we are ready to make a simple selection. So we need onCompleted function here. I'm using, I have here two variables. One is selected position, which takes pixel X position on my canvas. And I'm calling this onComplete, and selected position equals this onComplete position. So I know where user clicked on the canvas. And I have also selected bar, which is remember variable, and I'm using here derived state of to calculate my bar that is selected from this position. So as you can see in the remember function, I have two variables, selected position and bar areas, and this derived state of works like that. If any of those two will change, the selected bar variable will be calculated again. So whenever selected position will change, or my bar areas will change because I will reload the bar chart, then the selected bar will be recalculated and the composable will be recreated. And this is something that Damian mentioned. This is a stateful composable function, because I manage the state of the selection inside of this composable. So if we know already which bar was selected, we can now draw it. So in the draw scope, we are just checking if selected bar is null or not, and we are just using draw round rect, the same as we used for single bar. But right now the width and height will be a bit bigger to make the selection with a little bit alpha and transparency. So exactly the same function, draw round rank, but a bit different size and different top left corner of this selection. Now let's go to animation implementation. This is something that I struggled really a lot, because I wanted to make it as smooth as possible, and I also wanted to manage two states. One temporary state, when user are not entirely sure if wants to click at this bar. So we have this start animation, but user can always cancel that, and then the previous selected bar is still selected. So hopefully there is in documentation of animation for composables, there is this big flowchart, and I will go through this flowchart with you. So let's start at this green point, and for first I choose that animating content change in layout, I choose no, because my whole layout is not changing during the animation. So then the question is state-based and happened during composition. So in my opinion, it's not happening during the composition, because we have a stateful composable. So then there is a question if we need fine control over animation time. And we do not, because we start animation when user interact, and we end the animation when there is no interaction. So we do not need to measure or control the time of animation. So then the last question is animation is my only source of true? And the selection is always with animation. So the animation, in my case, is actually my source of true. So I choose animatable class to make those animations or bar charts. So animatable is quite easy to implement. You're adding just variable that remember its state, animatable of 0 floating number, and then you can see that in my onComplete lambda, I'm calling animatable animate to 1, and in my draw scope, where I'm drawing my selection, I'm just multiplying the height with my animatable value that is changing over time, and that gives me beautiful animation. So now about this state management, how to manage toSelection. I don't want to go into detail because there is really a lot of codes, to be written. So I will use here something like pseudocode just to give you an idea how this is implemented. But as I mentioned, you can check that on my GitHub repository that I will share after the presentation. So we have this selected position with mutable state of 0f, which is my position of the initial selection. And then we have a temporary position, which is minus int max value to be sure that I'm not selecting anything on my canvas. And then I have two animatable variables. One animatable is for my selection, and the second animatable is for my temporary selection. So go to this pseudocode. On my gesture started, I want the temporary selection to be my X position from the gesture started, and I want my temporary animation to start from 0 to 1. So I animate that to 1. Then in my gesture canceled, I want to cancel my temporary selection. So I'm putting there -1 just to cancel the selection. And I'm using this temporary animatable back to 0. So after user take the finger off, not take off, but swipe somewhere or use the second finger to cancel, then I'm canceling also my animation. So animatable goes to 0. And then the third one is onComplete. So when I know that the user completes the gesture, the click, I'm taking my temporary animatable and adding animate to 1 if it's not completed already. I'm passing this value to my animatable, and then I'm resetting the temporary selection, and the previous selected item is right now the new selected item, so my temporary selection. And I'm also resetting my temporary selection to -1. Probably sounds complicated, but if you would like to learn more about that, just give me a note in the chat or check my repository to learn more about that. At the end here you have the final result. As you can see right now, I can touch and long click, and my animation, temporary animation works. It's going, so the animation is always rising from bottom to top, and I can select temporary second bar, and if I will cancel it, it will not affect my selection. So right now, the last topic I promise is testing. I think testing composable views is really important. Testing your code is important, but having a good testing of your UI is something that not a lot of people are doing, and using composable testing API, in my opinion, is super easy. So before we begin this testing functions, I need to share with you those two things. One is that we'll test the entire bar chart canvas that takes two parameters. One is the list of values, and second one is which bar is selected. And in my row, I added the test tag modifier function, and I call it just bar chart. This is something that I'm doing to easily search for it during the tests. So, oh, sorry for that. Something, my background is missing. Yeah, I already said that. So the first, I just wanted to check the canvas existence. So I have here the compose test rule, and I call set content on it. And my content is obviously bar chart canvas. I'm not fulfilling bar selection. I do not need that yet. And I'm then calling on node with tag. I'm giving my tag that I set to this bar chart, and I'm just asserting its existence. And this is working. The verification passes. So we can go to second test. And the second one is click on the third element of the list. So I have here simple list with 8 elements, 1, 2, 3, 4, 5, 7, 8. And then I create my mutable state of first element to have something selected, to have something non-zero element to then assert this value with my selection. Then I need to know at which position I should mimic the click. So I'm taking here the distance 3 times. I'm converting them to pixels, and then I'm setting the content again for my bar chart canvas. Then I'm looking for this canvas with on node with tag, and then I'm performing gesture. It's easy as that. Just function perform gesture, and I'm performing click, and I'm giving this position offset with the distance I calculate. At the end, I'm just asserting that the selected item value is number 3. And this one also passes. And the last one I wanted to share with you is cancellation. So my selected item is as before, and the list is as before. The distance is exactly the same. So I'm clicking, I will click on the third item. I'm setting the content. Then I'm calling this on node with tag, but now I will perform different gestures. Now I will perform the gesture point down with this offset of given distance. Then I will perform gesture moved by. So without taking my finger up, I will move finger by the offset of the same distance, and then I will perform gesture up. So this should end up with canceling the selection. So I'm here asserting that selected item is the same as initial with this function, which is 1, and this test also passes, and that is the end. So my final thoughts about that: drawing using Composable Canvas is very similar to Android View Canvas, but a bit easier in terms of density, so this management of DP and pixels. Draw text is missing in Compose version. I hope it will change soon. As I said, it's P1 priority right now for Google Teams, so I hope it will be soon added. Testing is way easier than Android View System, and testing is really readable. Animation has a good documentation, as you saw this chart. And that's all from my side. Thanks you a lot for listening. And if you have any question, I'm open to answer, but